Alright, so we're just going to do one video for 3.12 apps of linear systems and 3.14 inequalities, which will make out to be two class activities. So class activity number one will be the apps for linear systems. So remember, we've learned how to solve them. There are three different ways. We have graphing, substitution, and elimination. So now we're going to actually use that in an application or a word problem. And then we'll take a look at some inequalities, so 3.14. All right, so let's take a look at class activity number one, which is going to be 3.12 apps of linear systems. All right, so I've written out the word problem. Okay, so Jill sells bubble tea at the farmer's market. A small sells for $4 and a large sells for $6. She made a total of 320 in sales last Saturday when she sold 58 drinks. To determine the number of drinks in each size sold, write a system of equations that would model the situation. State what each variable represents. Do not solve. All right, so sometimes you will be told to solve, but notice this says do not solve. So all they want is a system. So two equations. All right, so the plan that we have for writing a system. Okay, so plan for a system. So we're talking about a linear system. So what we need are two variables, like x and y, and two equations. So the question is, how do we find these? Well, the first thing we're going to do is look for the unknowns. Look for the unknowns. And make a let statement. With them. Okay, so remember, the unknowns are what our variable is going to be. So I'm trying to figure out, what do we not know? So normally we write, we look for the question or what we're trying to figure out. So reading through this problem, let's see, she sold, so this is all information. And then it says, to determine the number of drinks in each size sold. That's what we're trying to find. The number of drinks in each size. Okay, so what different sizes did we have? Well, we have a small and a large size. Okay, so we have a small and a large. All right, so we're going to say let, I'm just going to go with generic x and y. So let x equal number of smalls sold. And then we need one more variable, remember, so I'll let y equal the other thing I don't know, the number of larges. I don't know. Y equals number of larges sold. All right, so that was step one. We found our two variables. Awesome. Now we need to write two equations with these variables. Okay, so that's when it gets a little more interesting. Okay, so here's my little braces for my two equations. So the second step, we're going to identify the different units in the problem. So what do I mean by units? Well, for example, you might have miles and time. Or you might have dollars and quantity. So dollars and number of items. So let's look at our problem. What are we talking about? So a small sells for $4. Okay, so we have a money unit going on here. And a large sells for $6, another money unit. She made a total of $320, so another dollar unit. And then what is the other number? When she sold 58 drinks. Okay, so that's a number, 58 of the drinks. So it looks like we have a number quantity and then we have a dollar quantity. So for our problem, we're going to want to write two equations, one in dollars. So one equation in dollars. Where's my whiteout? I'm going to rewrite the word equation too. Equation in dollars. And the other equation we said was going to be written in the number of drinks. So one equation in number or quantity. Okay. So the third and final step for this. So make one equation in terms of 1 unit. So we said we're going to do dollars for 1. And another equation, or the other equation in terms of the other unit. All right, so let's take a look. So that's our plan. We're going to make our one equation in terms of 1 unit, we said dollars. The other equation we're going to make in terms of the number of items. So let's see. So we know that she sold 58 drinks. So the number of smalls she sold plus the number of larges she sold should end up being 58. Well, we said that x was the number of smalls and y was the number of larges. So x plus y, whatever these two numbers are, should end up being 58 drinks. All right, so we got one equation down. We need to make the other equation. So this one we said was going to be in terms of dollars. So let's look for our dollar amounts. So the small was $4 and the large was $6, and in total she made $320. So every time she sells a small, she gets $4. So one small would be $4, two smalls would be $8, right? Let me get a sticky note and show you what I'm thinking here. So if she sold one small, that'd be 1 times 4, which would be $4. If she sold two smalls, that'd be 2 times 4, which would be $8. If she sold 3 smalls, that'd be 3 times 4, which would be 12. But we don't actually know the number of smalls she sold. We just know we're calling it X. So to find out the number of smalls sold, the amount of money she made for that, it's going to be X, whatever number she sold, times the $4. The same will go for Y. Y will be Y times, how much does she sell larges for? 6. So for example, if she sold 3 larges, that would be 3 times 6, which would be 18. Okay. So this means that the number of smalls she sells, so 4 times however many, plus the number of larges she sells, which is 6, times Y, should end up equaling how much money? $320. Okay, and there we go. We have our system. Ooh, that was not the prettiest box. All right, so that was it for the class activity 1 for apps of linear systems. Okay, now we're moving on to 3.14, which is inequalities. Okay, so we're going to take a small look and solve. All right, so the thing about inequalities, let me grab my other paper here. All right, so the thing about inequalities is we're not looking for just one answer. Normally when we're solving, we're just trying to find one answer. For inequalities, we're looking at a large group of answers. So notice the symbol here, that's an inequality symbol. So this means greater than. So if I read this off, this would be 2x is greater than 4. Because remember, if we're thinking about, let's say, the mouth of an alligator, right? The alligator always wants to go for the bigger thing, okay? So 3 is less than 4, so the alligator is going to turn and try eat the 4 because it's bigger. So if I had 6 and 5, which way would the mouth be facing? Well, the bigger number is 6, so the alligator is going to want to eat the 6. All right. So solving this, well, it works pretty much the same as an equal sign or a regular equation. There is one trick, and we'll go over that in a little bit, but pretty much it works the same. So we're trying to solve for x. So to get x by itself, let's divide both sides by 2. And we end up with x is greater than 2. Okay, so we need to answer with a graph. So here's a graph. We're not going to use the normal Cartesian plane because we just have one variable. So x is greater than 2. Well, what I'm going to do, my boundary is 2. That's the number we're focusing on. So let's say here's 2. And my x value should be the bigger ones. So the numbers are bigger on this side of 2. Okay, so I just float my graph above. Now the question comes, am I including 2 in my answer or not? Well, x is just greater than 2. So we're not going to include 2 in the graph. If it was x is greater than or equal to 2, then I would fill in my bubble. All right, so number 2. So reading this off, 2x minus 1 is greater than or equal to 5. So notice that little difference here, or equal to. This one didn't have that line. This sign does. Same thing, we're going to try and solve for our variable. So let's add 1 to both sides. 2x is greater than or equal to 6. All right, solving for x. Let's divide both sides by 2. So x equals, or x is greater than or equal to, 3. Same thing, let's answer with a graph. So our boundary number is our answer, 3. And this says my x values are greater than, okay, so kind of similar to last time. They're the numbers bigger than 3, so on this side. And remember, I put the arrowheads to indicate that my answer goes on. They're greater than 3, but they are also equal to 3, which means I'm going to bubble in my answer because I'm including 3 in my answer. This was different than in this answer. 2 is not part of our answer. For this problem, 3 is part of our answer, so we bubble it in. All right, so we're going to do problem number 3, and this has that little trick that we're going to do. So if I have negative 2x minus 2, which is less than or equal to, actually no, sorry, wrong way, which is greater than or equal to 6. Okay, so go ahead, try to see if you can solve this. All right, let's go ahead and solve. So we're trying to solve for x as usual, so let's add the 2 to both sides. Minus 2x greater than or equal to 6, 7, 8. All right, so now this is where you need to be careful and pay attention. This is where inequalities differ from equations. Okay? So this is the important step. So notice, to get x by itself, I'm going to be dividing both sides by a negative 2. When we do this with inequalities, our sign is going to flip. Okay, what do we mean by that? Well, what's the opposite of greater than or equal to? It's less than or equal to. So that's the main difference. When we divide or multiply by a negative, our sign flips. So let me write that down. For inequalities, when we divide or multiply by a negative number, the sign flips. Okay, so when we get that, we have x is less than or equal. Remember, the sign flipped because I divided by negative 4. All right, so graphing our answer. Remember, our number is our boundary line, so negative 4. And my x values this time are smaller than negative 4. So numbers that are smaller than negative 4 are going to be on the left side. So here's my bubble. And we're wanting numbers that are smaller than negative 4. So we're going to take all these numbers over here. Now, do I fill in the bubble? Yes, I do, because I'm having it's less than or equal to 4. That little line right there. So I will fill in my bubble. All right, we're going to do one more problem for this class activity, and then we're done. Number 4. Okay, so 5 minus 3x is less than 7. Okay, go ahead, pause the video, see if you can solve this. All right, so solving for x, I want to get that 5 on the other side of the inequality. So I'll subtract 5 from both sides. And then what do I have? I have negative 3x is less than 7 minus 5 is going to be 2. Okay, so solving for x, divide by negative 3, divide by negative... Oh, I just divided by a negative number. Okay, so that means I need to flip my sign. Please flip it on the step. Okay, so I have x is greater than negative 2 over 3. All right, and graphing my answer for this problem, my boundary line is, or my boundary number, sorry, is negative 2 over 3. And my x values are greater than, so they're going to be on the right side. They're bigger. And are they equal to 2 over 3? Do I include negative 2 over 3 in my answer? No, I do not. They're just bigger than, not equal to. So I'm not going to fill in my bubble. And that's it. So the basic thing for inequalities, why it's different than equations, is when we multiply or divide by a negative, our sign flips, okay? The biggest thing I think to remember.